Hi everyone. Today we are going to go over Business Math A Lesson 9. The objectives for this lesson is so you will be able to apply the compounding interest formula, and you will also be able to demonstrate the relationship between compound interest and exponential growth. We're going to start off with some key terms. We have compound interest table. Is something I'm going to provide for you later, but it's a tool to calculate compound interest quickly. Compound interest is interest earned not only on the original principal but also on the interest earned during previous interest periods. Basically, you're earning interest on top of interest. Daily compounding is interest that is computed each day and is added to the account balance. The APR, or the annual interest rate, is the percent of the principal earned as interest in 1 year. The APY, which is the annual percentage yield, is the return or the rate of return on your investment for a 1 year period. Daily compounding tables, as I mentioned earlier, I'm going to share that with you. So to find the amount, you basically just take the original principal and you multiply that by the amount of $1, and that amount of $1 will be shown on the table. Compound interest is simply taking the amount and subtracting the original principal from that. So here are the steps to find the compound interest. So first, you need to find the amount of $1 for blank days using the given table. Second, you want to find the amount using the formula above. And then you can use the formula above, another formula above, to find the compound interest. So here's an example. On August 1st, Richard deposited $3,000 into a savings account that pays 5.5 interest compounded daily. That means every day you get a new interest amount. On August 23rd, how much interest has he earned on principal? So we need to know how many days he kept the $3,000 in the savings account. So that's the first thing. So remember, the 23rd, that does not necessarily mean the 23rd day because it started off as August 1st. So if you want to count, you'll see that there are only 22 days in between. So 22 days, all right? So let's take a look at the table. This is the table. Keep in mind that it is compounded daily. So if the question says something else, make sure you are checking the right table. Anyway, so we're looking for 22 days. So we look at the row where it says 22 and the amount is 1.00331. So basically, that means for every $1 you put in, you get $1.00331 back. That may not sound like a lot because it's per day, but when it adds up, it can make a difference. Alright, so we have that number. Now we need to find the amount. Remember, the formula is original principal times the amount of $1. Original principal is how much we started off with, which is $3,000, multiplied by the amount of $1, which is what we found in step 1, and that is 1.00331. Multiply together. That means after 22 days, Richard earned a total of $3,009.93. However, they're not asking how much he had in his account. They're asking how much interest did he earn. So you want to take the amount and subtract the original principal from there. That means after 22 days, Richard earned an extra $9.93. Alright, here's another example. Same thing. Stephen deposit $4,500 in an account that pays 5.5% interest compounded daily. So we want to know how much interest will he earn in 24 days. The nice thing about this question is it already tells you how many days there were. So all we have to do is look at the table and find out what is the value on the 24th or after 24 days. So it is 1.00362. Alright, step 2 is find the amount. Plug it into the formula again, original principal times amount of $1. So we have 4,500 times 1.00362. Multiply that together, we get $4,516.29. However, the question is not asking for the amount. The question is asking for the interest earned. So again, we subtract. So we have $4,516.29 minus 4,500. That means after 24 days, we earned interest, or Stephen better yet, of $16.29, which is pretty awesome if you think about it. An extra $16 after less than a month. If you were to put more in there, you'd get even higher. Alright, now I want you to try one out on your own really quick. I want you to pause the video and then resume it when you are ready. Alright, let's go over this question. So again, first step is to find out the amount of $1 for blank days using the given table. This time it doesn't tell you how many days, so we need to figure that out. So it started off on August 7th and it goes to August 30th. So that means there are 23 days, right? 30 minus 7, 23. So now that we have that, we can take a look at the table. And it is 1.00347. We're going to use that number for step 2. Plug it into the formula. We get 6,000 times 1.00347, which means Richard earned $6,020.82 after 23 days. To find the compound interest, subtract the two numbers, and you get $20.82. Alright, compound interest. So, as I mentioned earlier in the key terms, compound interest is interest earned not only on the principal, but also on the interest earned. So again, it's interest on interest. And the formula to find compound interest is given to you right here, where A represents the ending balance. How much do you have after a certain amount of time? P is the principal, is how much you start off with. R is the APR, the annual interest rate, in decimal form. So it's going to give it to you in percentage, just converted to decimal. N is the number of times interest is compounded annually. So if it says it's compounded annually, N would be 1 because it means 1 a year. If it's monthly, that means 12 would be your N. So keep that in mind. T is the number of years. So how many years is it in the account for? Alright, here's an example. Michael deposits $3,500 in an account that earns interest at 4.3% compounded quarterly. What is his ending balance after 3 years? So you know, in the first few slides we had a table for compounded daily. If you didn't have that table, you can still use this formula right here to find out the same value. You would get the same answer. For the next few slides, we don't have a table, so we actually have to plug it into the formula. Not as fun, but very useful. So, we're looking for the ending balance. You need to determine which variable represents the ending balance. In this case, it is going to be A. So if we're looking for A, we need to know what P is, what R is, what N is, what T is. So P is the initial amount started, which is the principal, and that's $3,500. R is the rate, which is 4.3%. Convert that percentage to decimal by moving it 2 decimal to the left, giving you 0.043. N is the number of times compounded annually. Because it is compounded quarterly, you know there are 4 quarters to $1, so there are 4 quarters to 1 year, and that's how I got 4 right here. T is the time in years. It mentions 3 years, so 3 is going to be T. So what we need to do is plug everything into the proper slot. We get 3,500 for P right there, R, 4, and then 4 times 3 for the exponent. Alright, now we have to worry about order of operation. That's PEMDAS. Alright, so we're going to start off with the P, which is parenthesis. Let's do everything inside the parenthesis first. But even within the parenthesis, we have 2 different operations. We have addition and we have division. This fraction bar is really division. So we're going to do division first. If you divide 0.043 by 4, you should get 0.01075. Got that down. Now let's add. We get 1.01075. After P is exponent. Let's evaluate the exponent. But before we can do that, we need to multiply the exponents together. 4 times 3 is 12. Now we can actually evaluate. You type in 1.01075 to the 12th power, you get a really, really long number. You do not have to write as many numbers as I did, but to be safe, at least write 4 or 5 decimal places, because if the question is fill in the blank, you don't want to get it wrong because you're off by 2 pennies or 3 pennies. So now that we have that, we can multiply 3,500 with 1.136907,156, giving us $3,979.18. So after 3 years, Michael would have this amount in his savings account. Alright, I want you to try one out on your own really quick. Again, pause the video, try it out. When you're ready to resume, click play again. Alright, let's try this one out. Again, we're trying to figure out what it is that we're looking for. The question says, what is her ending balance? So that means we're looking for A again. And because we're looking for A, we need to know everything else. P is the principal. How much did she deposit? $7,000. R is your rate, which is 3.8% or 0.038. If it's compounded monthly, we need to figure out how many months are in a year. As you know, there are 12 months in a year. That's why we have 12 for the number of times compounded annually. T is time in years, which is 5 years right here. Now, plug in everything into the calculator or do it by hand. It's really up to you. But we're going to do it by hand just so you understand how to do it. We're going to work what's inside the parenthesis first, so divide those 2 numbers right here, and you get 0.0031666667. Now we add that to 1, and then we do the exponent, which is to the 60th power. I simplified this, as you can tell, just because it might not make a difference. But if you're using a calculator, you can leave the whole number in and you're not really wasting time writing it out. Alright, evaluate that to the 60th power. We get 1.20888663813. Multiply that by 7,000. That gives you $8,462.21. So that's how much Rachel would earn after 5 years. Alright, steps to finding the APY. Remember, the APY is just the annual percentage yield, and that means after 1 year, how much interest would you have earned. So step 1 is to solve for A using the compound interest formula. Step 2 is to find the interest earned, which is amount minus original principal. And then step 3 is to find the simple interest rate, or R, using the simple interest rate formula, I equals PRT. These are the steps they mentioned to you in the book. We're going to go over that, and then I'll show you something a little bit easier. Alright, so here's an example. Suppose Jason opens up a savings account with $3,000 that compound interest daily. The APR at the time Jason opens the account is 4%. He makes no other withdrawals or deposits. So what is his APY to the nearest hundredth of a percent? So step 1, solve for A using compound interest formula. So same formula we've been using, plug in everything we know. We have the principal 3,000 right there. The APR is 4%, and if it is compounded daily, that means it is being compounded 365 times per year, because there are 365 days in a year. And notice that the T in this case is 1, because remember, APY just means the interest rate after 1 year. So we have that order of operation again. We get 1 plus 0.000109589, 4.04 divided by 365. Add that to 1, exponent, and then multiply by 3,000, giving us $3,122.43. Now we need to find the interest earned. If you start off with 3,000 and you earn $3,122.43, that means your compound interest is going to be $122.43. Alright, we have that. Now we need to plug it in to find the rate. So remember, I was $122.43. P, same principle, 3,000. We don't know what R is. We know T is equal to 1 year because, again, we're looking for APY. Plug in everything. We have 122.43 equals 3,000 times R times 1. Multiply the right side, these two numbers together, and you should get 3,000. To solve for R, you need to divide both sides by 3,000, giving us a rate of 0.04081. Convert that into percentage, which is 4.08 or 4.081, depending on what the question asks you to round. Is it hundredth? Is it thousandth? So on and so forth. So notice the APR is 4% and the APY is 4.08%. APY is always going to be higher than the APR because the APY takes into account the interest on interest that we talked about. Alright, so here's another formula. Not in the book, right? So I wrote this formula out and it'll give you the same answer. Remember in the previous slide, the situation, $3,000, 4% interest. So the APY was 4.08%. So remember that. We're going to use the exact same formula and hope that we get the same answer. Alright, so again, same example, 4,000, 4% APR. We're looking for APY to the nearest hundredth. So let's plug it into the formula that I gave you. We have 1 plus 0.04 divided by 365 times 365. I'm sorry, to the exponent of 365 times 1. And that answer minus 1. Order of operation again. 0.04 divided by 365 gives you 0.000109 589. Now exponent, we get 1.0408085 minus 1, which gives you 0.08085. Convert that into percentage and we get 4.08, which is the exact same thing we got in the previous slide. So notice in the previous slide, or better yet, previous two slides, we used three different steps. We had to find the amount, then we had to find the interest, and then we had to plug it in the interest to find the rate. But if you use this formula, you're basically just doing step one from the previous. Alright, I want you to try it out. You can use whichever one you want, the one from the book or the one I gave you. It's really up to you. But pause the video and then resume it when you are ready. Alright, let's try this question out. I'm doing it the easy way. The APY equals 1 plus r over n to the nt power minus 1. Plug in everything we know. 0.073 divided by 365, because again it is daily, to the 365 times 1 minus 1. APY equals 1 plus 0.0002 to the 365 power minus 1. So when we evaluate the whole thing, we get 1.075723 minus 1. So the APY is going to be 7.57%, which is higher than 7.3%. So keep in mind, I don't know if you noticed this or not, but when we're trying to find the APY, honestly, this does not matter. Had this said 10,000, it still would have given you the same APY. And that APY depends on the interest and the rate. I'm sorry, the period and the rate. So that's what matters. The principal does not matter when we're looking for APY. So keep that in mind. Alright, now we're going to take a look at graphs. Compounding graphs. So this graph shows the exponential rise in balance on an initial investment of $400 over 13 years at a 7% APR. So we want to know how much interest has earned or has the investment earned after 10 years. So we're going to round to the nearest $100, and that's because when it's talked about in the workbook and checkpoint, you don't want to, be off by a few dollars and get it wrong. All right? So we're looking for the compound interest, which is the amount minus the original principal. Looking at the graph, the legend says the red is your balance or the amount, and then your green is the principal, how much you start off with. Plug in everything you know. 800, right? After 10 years right here, that is about $800. 5, 6, 7, 8, 9, and then 1,000. So be very careful with what those numbers say. So we have 800 minus 400. That means the compound interest after 10 years is $400. Alright, here's another example. This time, we're looking for how many years did the investment earn $300 in interest. So again, it's starting off at $400 right here. That's 400. So we're trying to find where the balance is 700, right? Because 400 plus 300 is 700. So the balance is 700. Looking at the graph, 700 is right here. Right, so there's a line, kind of helps you figure it out. And draw a vertical line. That's what I did just to see, let it be a little bit easier. That should be approximately 8 years because from 5 to 10, this line right here is 7.5. So we're just estimating. And in the in your workbook and checkpoint and exam, they should be multiple choice, so they're not going to trick you with 8.25 or anything like that. Alright, one last one. I want you to pause the video really quick, try it out, and then resume when you're ready. Alright, let's try this question out now. So we're looking for the interest earned after 11 years. So let's see, where is 11 years at? Right, that's an approximate. Again, it's asking rounded to the nearest $100, so don't stress out too much about exactly where 11 years is. So I drew a straight line up to help you out, and then, as you can tell, that's about $1,400 or so, because it's 1,000, 12, 14, 16.